Prema Malar. I'm going to talk about the feasibility study of ethylene production from ethane. So first, cracking ethane can be visualized as a free radical dehydrogenation reaction where hydrogen is a co-product. The reaction is highly endothermic, so it is favored at higher temperature and lower pressures. Superheated steam is used to reduce the partial pressure of ethane and reduces carbon deposits that are formed by the pyrolysis of hydrocarbon at high temperatures. Additionally, the presence of steam as a diluent reduces the hydrocarbon's chances of being in contact with the reactor tube wall. Deposits reduce heat transfer through the reactor tubes, but steam reduces this effect by reacting with the carbon deposits. Many side reactions occur when ethane is cracked, where propene and 1-butane are produced from free radical reaction and beta scission of the carbon-carbon bonds. The newly formed free radical may be terminated by abstraction of a hydrogen atom, or it may continue cracking to give ethylene and a free radical. The produced free radicals further crack to yield more olefins. In the furnace and in the transfer line exchanger, catalytic coking occurs on clean metal surfaces where nickel and other transition metals used in radiant tube alloys catalyze dehydrogenation and coke are formed. The radiant tubes gradually become coated with an internal layer of coke, thus raising the tube metal temperature and increasing pressure drop through the radiant coils. Coke formation reduces product yields, increases energy consumption and shortens coil service life. Coking is related to feedstock temperature and steam dilution. When coke reaches an allowable limit as indicated by a high pressure drop, it should be removed. Coke should be reduced by adding antifoulants which passivate the catalytic coking mechanism. Significant improvements have been made in this design and operation of high severity pyrolysis furnaces. Usage of modified nickel chromium ferrum alloys for tubing has enabled raising the temperature, shortening residence time, lowering pressure drop in cracking coils and increasing their long-term strength. A typical ethane cracker has several identical pyrolysis furnaces in which fresh ethane feed and recycled ethane are cracked with steam as a diluent. The outlet temperature is usually in the 800 centigrade range. The furnace effluent is quenched in a heat exchanger and further cooled by direct contact in a water quench tower where steam is condensed and recycled to the pyrolysis furnace. After the cracked gas is treated to remove acid gases, hydrogen and methane are separated from a pyrolysis product in the demethanizer. The effluent is then treated to remove ethylene, and ethylene is separated from ethane and heavier in the ethylene fractionator. The bottom fraction is separated in the deethanizer into ethane and propylene, butylene and higher fraction. Ethane is then recycled to the pyrolysis furnace.